Hello. సార్ వినిపిస్తుందా సార్? హలో.
Hello. Yes, sir. You are audible.
ఓకే సార్, ఓకే సార్.
Hello.
Audible, sir.
సార్ ఆడిబుల్ సార్?
Yes, sir. Audible, sir.
ఓకే సార్, యువర్ వాయిస్ ఇస్ క్లియర్ సార్.
సిస్టమ్ మామూలుగా మాట్లాడారు. మామూలుగా సిస్టమ్ చేశాను ఏది
ఎంతమంది అయినారు?
మనం మాట్లాడే
మంది వచ్చిందా? Good morning, all of you. I welcome all the students and faculty from different regions of the state and across India. So far, there are, apart from Andhra Pradesh, there are teams coming from Tamil Nadu, Telangana, Himachal Pradesh, Punjab, Rajasthan, and Karnataka. These are some of the states who are actively involved in this hackathon activity. I welcome and appreciate all the faculty members who are very actively engaged your students. So this is a very important a training program. It is a a precursor to the hackathon. As you all know that our government of Andhra Pradesh, Honorable Visionary Chief Minister Garu, has a vision to make Amaravati as a Amaravati Quantum Valley. In this connection, from APSE, AP State Council of Higher Education, Professor K. Madhumurthy Garu, Chairman of APSE, has designed various activities to connect with this Amaravati Quantum Valley, particularly the 156 qubit IBM quantum computer. So in this aspect, our chairman, Professor K. Madhumurthy Garu, has a mega plan regarding establishment of quantum teaching labs in every college, and also the submission of proposals for quantum algorithms, which gives a huge impact on this 156 qubit machine. And these are one vertical, and another vertical is training all the faculty across the state. All our state universities, including private colleges, engineering colleges, even agriculture colleges and medical colleges, and general degree colleges. We are now conducting India's largest faculty development program. Almost more than 1,000 people are undergoing training with the support of IBM, TCS, IIT Madras, MNIT Jaipur, DST, and National Quantum Mission. All these are parallelly going. Not only that, as per our vision of our Honorable CM Garu as well as our Chairman Garu, we want to produce at least 50,000 students by the end of December. So this is hackathon is one of the best way to train the students and inspire the students, and also create an awareness among the students. Not only this, so I think so far we have received almost 3,500 teams. A team is considering at least 6 members. This is a maximum is 6 members. So in this way, approximately there are around 20,000 people, students across India, and mostly belong to Andhra Pradesh. So I appreciate all the participating states as well as participating universities, colleges, both engineering as well as general education. So you are now considered as a quantum enthusiast. So all the young generation now, they are going to lead this quantum nation and quantum state, which is coming up in Amaravati Quantum City. So this is India's the largest facility. Even if you consider across the world, it will be maybe second or third largest facility having a 156 qubit computing system. So in this connection, APSE has come with so many initiatives, and one such initiative is conducting Amaravati Quantum Valley Hackathon 2025. First of all, on behalf of APSE, I congratulate all of you, particularly our SPOCs, who are faculty who are involved very much, very enthusiastically. They are real advocates of these quantum initiatives. So whether it is not only limited to purely physics people, chemistry people, or computer science people. We have given choice, we have given chance to everybody, whether it is social sciences or arts or core engineering subjects, agriculture subjects, everybody, because everybody has a role in this quantum system in terms of application, if not in technology. So today, we have two very enthusiastic resource persons. One is Dr. Mauli Garu. He is actually CEO of Incubation Center. And another is Dr. Professor Indrakshi Madam from BITS Pilani. Before that, I would like to give a brief introduction of why we have chosen this platform for this conducting of hackathon. I would like to present 3-4 slides for your benefit. So as I said, the bootcamp is a precursor for this real hackathon. So today, incidentally, is the Entrepreneurs Day. So as you all know that August 21st is Entrepreneurs Day. because the World Entrepreneur Day is celebrated on August 21st. This is actually, if I ask any student, you name who is the greatest entrepreneur, you name him as the man who is known for all the students, that is the Steve Jobs. The only way to do great work is to love what you do. So here we are trying to connect you and to immerse you in this quantum technology. So an economist, a very famous economist, Austrian American economist, also said that for his renowned theories on entrepreneurship and innovation, this day was identified as the World Entrepreneurs Day. So we want to encourage your innovations. We want to promote you to become a job giver and to make you an entrepreneur and to promote the startups. So as you all know that India is promoting startups in different verticals, different levels, whether it is school education, higher learning. In school education, you will find the adult tinkering labs in every school, particularly the government and Jilla Parishad schools. Whereas in colleges and universities, you will find institutional innovation centers. And yesterday, our Honorable CM Garu launched Ratan Tata Innovation Hubs. Even every hub, you can go and you can experiment your ideas in the Ratan Tata Innovation Hub. You will find in Vizag, you will find in Amaravati, that is Mangalgiri, you will find in Tirupati, you will find in Anantapur. Everywhere there are hubs. So it is a very important chain connecting from adult tinkering labs to institutional innovation hubs and also Ratan Tata incubation hubs. Next slide, please. So why we have chosen this? If you observe these graphs, India is just immediately second to USA when it comes to startups. Now in 2025, after US next week, after US, the biggest capability of India is we are second to none. We are second to none. If you consider that around 348 startups are there, which are in a business model. In a business model means it is having some millions of stake in this. Whereas US is 1,087. This is it is in terms of value. So even in that 1,873, most of the startups coming from Indian people only, Indian origin people only. This is the capacity of Indian students. Next, please. So with 1.5 lakh startups as on today now in India, we want to make you a part of Amaravati startup, because surrounding this Amaravati 156 qubit computer, there are so many startups are coming. Even within this month, there is 8-bit qubit computing is coming from Bangalore to be established in Amaravati. So every student will have a role. It is a mandate by our chairman, Professor K. Madhumurthy Garu, to design a certificate course for you, all of you. So I would like to take this platform to inform you that we want to train at least 30 to 50,000 students by December through various activities like boot camps, like hackathons, and we also want to introduce the certificate course also. So this is the potential a single quantum computing technology can have in our Amaravati within your neighborhood. Thank you. Next. So these are actually, as per the vision of our Honorable CM Garu, he want to create everybody as an entrepreneur. So every house should produce one entrepreneur. This is the concept. So far these are the IT services, healthcare and life sciences, professional and commercial services, education. There is a strong demand. It is as per the skills report of 2025. Next, please. So we want to make you as a job giver instead of job seeker. So it is not new actually. It is already completed 100 years. So it is 100 years of quantum is just a beginning. Actually, it is a slogan by UNESCO, and they are promoting. And on these aspects, we are also APS is also going to promote this. Next, please. So there are infundable opportunities. Just I clicked today's LinkedIn post, they have several job opportunities are there within the quantum. Next, please. So these are the opportunities. These are the opportunities. There are industry opportunities are there. There are academic opportunities are there. There are research opportunities are there. In every field, quantum is there. So don't think that quantum is a new subject. It is a 100-year-old subject. And don't think that this quantum is only for physicists or computer science faculty or mathematicians. No, not like that. It is for everybody. Even we are including commerce people from higher education. Even we are including economics people. Even the enthusiast. So many life sciences for drug designing and other activities also we are including. So the sky is the limit for your innovations. Next, please. So recently, as you all know, that Honorable CM Garu launched the quantum compute, this thing, a replica of the 156 qubit IBM machine. So our Honorable CM is there, our Honorable Chairman APSHA is there. So they have launched this. By 1/1/26, we require at least 1 lakh students to be job ready to work in this IBM 156 machine. So this is the background why we have chosen this platform to conduct for all the students online the boot camp. Next. So with this, I think you have connected with this all the background. So recently, there is a 2-day workshop on quantum computing at WIT, Amravati. Our brochure, that is Hackathon brochure, is launched there in the August presence of the scientists and CEOs of IBM, TCS, and so many startups, right? So this is the background why we have commenced the hackathon. With this, I think you must have understood what is the nitty-gritty of what is the importance of this. So dear students and Spox, we have shared the YouTube link for the benefit of students who cannot connect, who could not connect at this time. I request all the Spox to share the YouTube link to your students, and I request all the Spox to please facilitate the watching of this. And at the end of the session, now I will I will invite our today's resource person. There are 2 resource persons today. And before that, I would like to announce that there are 5 semi-final rounds are there. The venues are Gayatri Vidya Parishad College of Engineering, Visakhapatnam. So this is the venue covering Visakhapatnam, Vijayanagar and Srikakulam. All the Spoks should connect with Dr. Anuradha Madam, who is a Spok there at Gayatri Vidya Parishad. So they will coordinate with all the Spoks at rest of the colleges in Visakhapatnam, Srikakulam and Vijayanagar. And they will also help you in conducting internal hackathon. So after this internal hackathon, they have to conduct the semi-final round at that college. And for East Godavari and West Godavari, the SRKR Engineering College, Bhimavaram, is like a Spock college. Dr. Ravikiran Verma is there, the Spock from SKR Bhimavaram. So you can connect with him. And for Krishna, Guntur and Prakasham districts, Dhanekala Institute of Engineering and Technology, Vijayawada will be the Spock. So Dr. Madhukant Ravi Garu will be the Spock for Dhanekala. And for Sri Padmavati Mahila Vishwavidyalaya, the districts are Nellore, Chittur and Kadapa. So the Sri Padmavati Mahila Vishwavidyalaya, Tirupati will be the Spock for these districts. So Dr. Suri Kumar Garu will be the Spock for this. You can connect with him. And for Anantapuram and Kurnool, J.D. Anantapur is the Spock, and Professor Sumabindu will be the Spock for this. You can also connect. With these a few introductory words, I now request today's resource person. He is involved in so many Atal Tinkering Lab activities. Actually, he's a CEO. And not only that, he is a nice speaker, and he is handholding so many youngsters in his Atal Tinkering activities and Smart India Hackathon. His expertise in Smart India Hackathon. He is also looking after the Institutional Innovation Councils and Entrepreneurship. Now I request Dr. Mauli, he is CEO and Innovation Catalyst at Atal Incubation Center, SKU, Sri Krishna Devaraya University. He is also mentor for Atal Innovation Mission, Niti Aayog and Startup India, and Innovate Bhutan, ecosystem builder, a strategist, a startup coach, enabler, and at the rate of Ministry of Education and also AICTE. including IIC, that is Institutional Innovation Council. He is a change enabler, and the very important aspect of his hobby is supporting undeserved cricketers also. This is his hobby. Now I may request Dr. Mauli Garu, the CEO of Atal Incubation Centers, Sri Krishna Devara University. Please, the floor is open for you, sir. Please take the session. I welcome you.
Thank you, sir. Thank you very much. Before I start, am I audible? Yeah. So good morning, everyone. First of all, I would like to congratulate AP State Council of Higher Education for bringing up the quantum computing, which is 100 years old technology, to the limelight, and especially to the grassroots level, to the nation. Okay. So congratulations, sir. And this is a very, very divine work you are doing. And also one suggestion from my side is you can also bring the student teams or students, faculty who are participating in this quantum revolution. You can make them as quantum ambassadors, okay, for their institutions and for their regions. So with this brief, so let me share my screen if it is available. Yeah. So thank you again, Apshi, for giving me this opportunity. Hope my screen is visible. So I'm Dr. Chandramouli from Atal Incubation Center, Sri Krishna Devara University. We are supported by Atal Innovation Mission, Niti Aayog, Government of India, and AP Innovation Society, Government of Andhra Pradesh. Today, I'm going to talk about how student innovators and the faculty can prepare their own roadmap to AQVH 2025. Okay, so let me start. And before we start, let me tell about my organization within a couple of minutes. Ours is an incubation center where we support innovations and startups. And we support innovations and startups in the field of agri-tech, food processing, clean energy, and circular economy, as well as into the deep tech. Okay, so deep tech in various sectors, we focus edtech, healthcare, biotechnology, so many more. And the core values of our institution is we want to reverse the talent migration by creating more job opportunities through entrepreneurship and boost the local economy through innovation and entrepreneurship in small towns and the rural areas. That's what our core value is all about. So what we did so far, ASSK programs throughout the years. We have outreached more than 1 lakh plus students across Andhra, Telangana, of course, Karnataka, Tamil Nadu, and Maharashtra as well. So ours is an incubation center supported by Government of India, and we work pan-India. We have 55 plus startups incubated at AICSKU, and starting from Punjab, Odisha, Kolhapur, we have all the regions covered with our startups. And our startups has supported more than 20,000 farmers. That is the kind of impact our startups are creating. And the startups got more than 15 plus awards, national and international awards. And AICSKU has recognized as best rural incubation center in India by ISF in 2024. So, and also we support higher education institutions in building their sustainable and vibrant innovation and startup ecosystem in their institutions for continuously 3 years. Okay, so this is our unique value proposition, and this is appreciated by Atal Innovation Mission also. And they have recommended to most of the Atal incubation centers to follow the same pattern of enabling the startup ecosystem. And not only this, our startups created more than 300 plus jobs and facilitated 300 plus lakhs of, we facilitated 300 plus lakhs of fund to our startups directly. And indirectly, my startups has raised more than 1,000 lakhs of, funds. And we have 3 online courses specifically focusing on innovation, entrepreneurship, and venture development, including design thinking, how we can develop the IT companies, software engineering, all this stuff. Okay, so anyone can enroll and you can have the courses. Coming to today's, brief about the hackathons. Before we delve into the hackathon, how this hackathon works, and the students' understanding of hackathon, let me give you the procedure of how to innovate first. Okay, for that, I'd like to introduce the innovation landscape and how we can demystify this for this particular hackathon. Okay, when it comes to the innovation landscape, this is what the standard innovation landscape that we teach to most of our students. The first stage here in this innovation landscape is identifying the problem or problems. Then we have to list out the problems and then prioritize the problems. And when we can prioritize these problems, when we have clear market research with our customer segments or the segmented people. Okay, so then only we can prioritize the problem statements. And also, you should validate the problem statements. If you are not validating, that means you should understand how big is the problem. And this can be done through market research again. You can do this market research through various resources. Okay, so through the Google Forms, you can have your own questionnaires and share it with your customer segments. Then they can give the answers. Then you can summarize that. So that's what the validation. Then after summary, you have to come to a point that how many members are exclusively suffering these problems. So then that's what the validation is all about. And then you can also come to the conclusion and validation through few annual reports based on your problem statements. Okay, so you can, if you have a problem statement for an agriculture problems, then you can go to the agriculture departments of state and central government. You can download the annual reports and you can find out your own data in that. And if you are working on road safety, you can go to the MORTH, then you can download the reports, then you will find most of the data there. Okay, so already, curated data you can find. So no need to again work on the same things. So that's how you have to identify the problem and validate the problem through market research. Then the second stage is how you can define the problem statements. After writing the problem statements, how you are defining that. Are you combining 2-3 problem statements and writing it to one problem statement? Or you are dividing 5-6 problem statements into 2-3 problem statements? How you are doing this? Okay, so that is very, very important because most of the students and the faculty they don't do all these works. They directly go and execute the technology. Okay, and the next important step is ideation, bringing up the solution. And also you should work on what are the existing alternatives. Then what benefits you are giving to your customers and all those things, you have to look in the ideation stage itself. That's what and also you should look how you are solving the problem, whether you are correctly solving the problem through your solution or not. That is what the problem solution fit is. And then does your solution fits to the market? When I say market, that means to your customers. Okay, so that also you should see at this stage itself. Then the next stage is whatever the solution you are thinking and visualizing, put it on the paper. Okay, make sure that you are sketching a concept on that. Okay, a flow chart or whatever it is. Then after that, prove the concept, prove it in a laboratory with the small simulation tools. Or if it is a hardware, solution, then put it on the breadboard. Okay, try to, code using microcontrollers. Okay, so then definitely, if you got the proof of concept, then go to the prototype. And when I say prototype, that is the real world minimum viable product you are going to design. Okay, and this prototype, here you are checking your solution with the real-time inputs. So not with the simulation inputs and all those things. Okay, that's why we are calling it as the prototype, not the proof of concept. Proof of concept is different. That's what you are doing in lab. And prototype is what you do for the real inputs and what is the output you are getting. And then test it, validate it. This is another very important thing. If your product is, eligible for licensing certifications, then do this at this stage itself. Then the next stage is go to market strategy and then marketing and sales. This is the total innovation landscape that we ASSKU developed, and we preach to the students and faculty and most of the innovators as well. Okay. Why I'm telling this? Because when you are solving a problem, every student or faculty, you should not keep this in your laboratory, or it should not be for the sake of a article publication or patent publication. How you are making business out of this, how you are bringing the solution and converting that solution into innovation and manufacturing that into a product and giving it to your customer, how you are doing this. That's why I'm putting all the innovation landscape here. Then coming down to the hackathons. Okay. The biggest challenge for any innovator to go through all these steps is the first two steps, the problem identification and validation, and then defining the problem statements. Then the last two steps, go to market, identifying the market, satisfying the market, and then selling your product. These two, first two and the last two steps are very, very difficult to any innovator and business person. And also, linking this problem solution fit and solution market fit is also very difficult. But when it comes to hackathons, in hackathons, what we are doing is, hackathons usually do in a very, very, I should say, they all relax your, difficulties. Okay. The hackathon procedure usually happens, they will list all the problem statements. And for that problem statements, usually the industries, governments, corporates will give the problem statements to the organization. Here, in this case, APSHI is the organization, and they will be rolling out all the problem statements. And the innovators, the students and faculty should come up with the solution part. And then they have to just work on how they can implement the solution, how they can benefit the customers, and how it brings the impact. That's what your work is all about. And that is where I think most of the academicians are very special about. When it comes to the hackathons, also the AQVH 2025 process, you have all the problem statements listed in the website. Take the one of the problem statement and then work on the ideation, validate the solution, then sketch up the concept, simulate it, work at the laboratory level, prove the concept, then come up with the prototype, and then just go ahead and test it, validate it. These are the steps that most of the hackathons and the current AQVH is also working on the same thing. But to explain AQVH 2025 process altogether, I came up with a case study because when I called Anil Garu suggested that, sir, since we have students and faculty, we need a case study where all the presentation, how they have to prepare, what they have to keep in mind, we have to talk all about these things. So that's where I thought bringing up a problem statement, where I used to listen whenever I go to the colleges. I visited more than 500 plus colleges, and the common problem statement I get is, sir, how we can reduce the commission agents between the farmers and the consumers or the retailers. That's what the common problem I get. So that's why I took that problem statement and I have written in a very, very classical way here. So problem statement is optimizing agricultural supply chains in rural India, basically the rural India, using quantum computing and artificial intelligence. That's what my problem statement is. It appears to be more solution, but it is the problem statement. Okay. So now let us delve into the slides that have given by the APSHI. Okay, APSHI has given you the total 7 slides, and out of which the first slide is more on the information problem statement. The second slide to fifth slide is more on the idea slide, implementation slide, and also the technology slide, impact slide, benefit slide kind of things. Then after that, we have references and then thank you slide. Okay, this is what the total 7 slides. But here I will be talking more about the second slide to fifth slide. That's it. References and the learnings you can put on your own. Okay. So then coming to the first slide, see, today my presentation, I am putting more content here. But when you do your presentations, don't put more content. Make sure that you are putting images, photographs, infographics, so that it is more attractive when you present. Okay, so now what I'm doing throughout these slides is I'm putting what students has to prepare and talk about for each slide. That's what I'm doing here. And then what they should keep in mind while they talk and prepare. These are the 4 points I'm covering for each and every slides. Very simple. And these slides and the content I'm putting here, this is very much useful to all the faculty and students. If you are planning to apply for any hackathon, not only this hackathon, for any hackathon, it is very much useful for also Smart India Hackathon as well. Okay, and also these slides, if you prepare for your innovation or the problem statements, then this is also very much useful if you are applying for any grant under Nidhi Prayas or MSME, Ideathon, anything. So for that also, it is very much useful. So guys, I will also share these slides to you. Don't take any photographs or screenshots. I will definitely share all the slides to you. Okay. So now coming to the idea slide, the first slide. Okay, what students has to prepare and while presenting, what they have to talk. Okay, the first and foremost important thing is they have to briefly restate the problem statement. When they are presenting the problem statement, make sure that you are coming up with a kind of small narration, small story, and also small data points. Okay. And if for data points, I think you can use Perplexity or Google. Okay. So where you can find more number of data based, and that will really validate your problem statement. Then coming to the proposed solutions, make sure that you will explain your idea with very simple English and in a very clear way. Okay, step by step procedure. Okay, so make sure that all the jury members, make sure that all the students, guys, all the jury members look them like LKG students, LKG, UKG students. Then only you can brief them in a very understandable way. If you are thinking that the jury members are experts, then definitely you are going to, miss a good opportunity. Right. So when you're explaining, make sure that you are very clear about your solution and use a simple language. And if possible, take the real-time examples. Okay, real life examples. Okay, and where you can easily relate your solution to the problem solving. And make sure that your problem is solving all the pain points that have listed in the problem statements. Okay, and also highlight the benefits and improvements over the existing systems. To list all these things, what you should know and you should do some kind of market research. What are the existing alternatives or solutions already existed in the market? Then you are the better person to write the benefits and improvements for this. Then the very important point is the innovativeness and uniqueness of your solution. And that makes you stand out of 100 or 200 innovators aside. Okay. Explain what makes your idea very different when compared to other solutions. Okay. Try to come up with some novel features, and that features should give benefits to the customers or the people who are using your solution. And also what kind of algorithms, advanced algorithms you are using so that you can reduce the power consumption or you can use maximum resources. Okay, so what are the approaches you are using? So just put all those things so that the innovativeness and uniqueness should be very strong for your solution. Okay, so then what you should keep in mind while you are preparing the solution and while you are presenting. As I told you, keep the language simple and jargon free. Use more visual, treat like diagrams, infographics, photos, wherever it is possible. If you are working, if you have screenshots also, you can put the screenshot. Okay, so that tells that seeing is believing is what I always teach. Okay, if you are putting some photographs, definitely the jury and the people will believe that you did some work on this. Okay, avoid long paragraphs. What I'm doing here now. Okay, don't do so much of paragraphs and points. Okay, only put the key points, and also make sure that if you can put that key points into a good infographics, that is the more wonderful thing you can do. Do you want any tip here for converting your key points into the infographics? There is a wonderful AI tool that you can do with that. Okay, to all the faculty and students, I'm just giving this name only one time. This is napkin.ai. It is free version. You can go ahead and do lot of infographics with that. Napkin.ai, napkin.ai. Okay, if just give the key points, it will give lot of infographics to you. Okay, so then you be prepared to explain and also make sure that what type of questions this jury or the audience will ask you, just anticipate the questions, write the answers, prepare that way. Okay, then let us take the case study. Okay, I'm putting very more content here. Okay, just if I'm a participant, I will just put this way, I'm not this way. So problem recap. Farmers in rural India. When I say farmers in rural India, don't just say there are so many farmers in rural India. Then you should mention how many farmers are there. For example, I'm just quoting here. Okay, this is for the sake of example. There are 10 crore farmers in India. Okay, and they are facing significant losses. What are these losses? Okay, you have to give the quantifiable data here. Okay, and this is due to the inefficient supply chain management. And what is that supply chain management? You should take one or two existing supply chains and you should explain here. Okay, be it transportation, be it a broker system, or be it demand and supply issues, or be it the price hikes. Okay, whatever it is, you should clearly mention in 2024 the price hikes for the mirchi farmers went this much high. That's why this many mirchi farmers are not happy with these things, that thing. So you should mention very clear data. Okay. So if you're not putting the clear data, that means you have not worked. And most of the people don't want this ambiguity data. Okay. We want very, very clear data and the narrow data. Then the proposed solution. My solution name is AgriQchain. That's what I'm doing. And it's a AI plus quantum powered platform and a computer or mobile app I'm bringing in here. Okay. I'm using more quantum algorithms to optimize the transportation routes, rate hikes, and also the climatical changes. So more I can keep here. Okay. And also I can create the AI driven demand forecasting here, and also the real price insights I can give with my solution. Then how it solves the problem? It reduces wastages by predicting where and when to send produce, the farmer produce. And it will ensure farmers get better prices by matching demand and supply as much as faster it is possible. And it also enhances the transporters, wholesalers, and end consumers. And what is the uniqueness you are bringing in here? I'm bringing in here, we use quantum annealing to process millions of supply chain and megabytes of data. Okay. And what I'm doing, I'm integrating predictive AI and quantum optimization as first of its kind approach for agriculture in India. That's what my uniqueness here. No one has used that. That's what my approach here. I'm just putting this as case study here. This is only for idea slide I am putting. Okay. So now the technical approach. Let us take the technical approach. What you have to prepare and what you should talk in the technical approach. Now, the technologies to use, what kind of technologies you are using or tools you are using, or the support you are using from different sources. Okay, be it programming languages or be it frameworks, APIs, or AWS, whatever it is. I have written the examples also. It may be Java, or it may be Python, or it may be SDKs, IDEs, IBM Qiskit, AWS, whatever it is, what you are exactly using the technologies. And also make sure that you should include the TRL levels here in this particular slide. The technology readiness levels. Okay. What is your technology readiness level? Okay. There are total 11 steps in the technology readiness levels. Go through it and put the technology readiness level total map and put that where you are exactly. TRL 4 or TRL 5 or TRL 10, where you are exactly. Okay. So then what is the implementation methodology you are doing? So bring up the step-by-step procedure. Okay, how your solution will be solving the problem. You should present in a step-by-step procedure. Use a flow chart, okay, or a block diagram, or a concept, or prototype image, infographics, so that the implementation methodology is neatly understandable to the audience, whoever it is listening. Okay, then if you have a working prototype or a demonstration plan, if possible, bring it to the jury, or bring it to your colleges. So there are some spoke colleges. You can go there and you can present it. Okay, and explain them. Give them a demonstration as if they are customers. You are the startup. Okay, and the working model always give more high than whatever you just present in the slides. Then what you should keep in mind when you are presenting the technical aspects. Okay, keep the technical depth which is aligned with the quantum Amaravati Quantum Valley Hackathon expectations. Okay, so don't be so shallow, okay, or too complex. Make sure that you are optimizing your presentation on the technical details. Okay, so how much this particular hackathon is required, just present that much, otherwise the total thing, whether if you are too shallow, it is a problem, and if you are too complex, it is also a problem. Okay, use visuals as I told you already. Okay, be prepared for technology based answers. Anticipate all the questions, write it down, and you just wrote the answers. Okay, you do mock pitches with your friends itself. Okay, when you're developing the technology. Now, when we go down to the technical approach, the user case study, what I told you, the technologies we are using here is Python, C++, and the framework IBM Qiskit, TensorFlow, and of course the cloud infrastructure AWS or IBM Quantum Cloud I am using, and hardwares, of course, IoT based sensors and microcontrollers. We can write here the technology stack, we usually call it as. And the implementation methodology, this is how you have to present the step-by-step procedure. Data collection. And I missed one point here, and you should also add that one point. That one point is, when did you collected the data? You should write the date, or you should write day one or day two. If it is the plan, then you should write day one, day two, that way. If you have already completed that, then you should mention the particular date or particular period. So April 2025, I have collected the data. Okay, May 2025, I have processed the data. Then I used algorithms for prediction, and the program was successful between the months June and July. Okay, and what is the process it was involved in for these steps? And also what kind of tools you have used? This is what the implementation methodology. And in the implementation methodology, if you are writing the timelines, and that is a wonderful thing that every jury member and every grant giving organization will definitely accept it, and they will feel that you did a lot of good work. Okay, I hope I'm audible and it is good with the flow.
Yes, sir, audible.
Yeah.
It is fine.
Okay. All right. Right. So I'm just putting you here the flow diagram. Okay. Or you can say the flow chart or block diagram, whatever it is. Okay. So first, in the first step, I'm putting the IoT sensors. Then I will process the data, whichever the data I receive from IoT sensors. I process the data. And then I will use AI for predictions through AI algorithms. And then I'm also using the quantum optimizer. Okay. So for predictions, but for better predictions, I should say. And then I'm integrating that with the farmer app. And I can present this with the simple steps also. But this diagram will give, a good eye treat to the people, right? Okay. And guys, I made this using Napkin AI, this diagram. So then, yeah, coming to the next slide. Sorry, before I start here, any questions, or shall we take the questions at the end?
Sir, better you can take at the end.
Okay. All right. So now let us talk about the feasibility and viability slide. Okay. What is the technical feasibility and what is the financial feasibility or viability or business viability, we should think here. Okay. If you take the feasibility analysis, first you need to understand how this idea or whatever the idea you are putting on your paper is technically possible with all the tools available, be it free tools or paid tools, whatever it is, and the skills you have. Okay, so you should also map that skills with your team members. If you don't have the skills, try to contact your faculty member. Most of your faculty members might have all the skills and they know how to get the tools as well. Okay, if you're not doing that, going and talking to your faculty, then you're doing a big mistake. Or what you can do is for financial viability and business viability, and to come up with approximate cost, we usually call it as cost structure. What students can do is, if you have an incubation center in your college, approach your incubation center and they are the better persons who can give you this financial viability, business viability, cost structures for your solution. Okay. So then for the challenges and risks also, you can talk to your incubation center people there. Okay. Mention potential limitations technically, cost wise, and also skill wise, also resources wise. Okay. And very much important is user adoption as well. What are the challenges? If I come up with this solution, does the farmer catch this solution and use this? Okay. If I come up with a smart solution that requires iPhone 16 Pro Max, and does every farmer uses iPhone 16 Pro Max? No, right? So you should do so that your solution can be user adopted. That is very much important. So then you should come up with a small app which can run in the basic smartphone with Android or iOS, whatever it is, the basic version, it should work. And it should have, if it is a standalone app, it's a wonderful thing. Okay. Then the risk mitigation and strategies. You have all the risks you have listed in that section. Now, what you have to do is you have to strategize how you are going to work on minimizing the risks. Okay. Explain how you can handle these risks. Do you have any team member who can handle these risks? Or do you have any mentor or advisor for your team so that they can help you in handling these risks? Okay. So for example, I'm just putting one example here. To overcome data scarcity, we will use open data sets and synthetic data generation. This is one of the technique we are using technically. Okay. So like this, you should clearly mention what exactly you are doing with risks and risk mitigation strategies. Okay. Here, guys, you should keep in mind that in this feasibility and viability slide, you should take help from people, help from organizations, help from tools, resources, and also the users. Okay, this is very important. If you develop a solution which is not adaptable by your customer, then it's not good. Okay, right. So let us jump to what you should keep in mind while you are doing this. Okay, be realistic. Okay, so don't be so optimistic, but be realistic. Okay, show that you have thought through risks carefully. Okay, and viability process, the financial aspects. Okay, avoid vague statements. Don't give vague statements. Sir, our product will cost around 50,000 rupees or 50 lakh rupees. We want that 50 lakh rupees to do this. Then they will ask, what is the cost structure? Please give the cost structure in Excel sheet. Okay. Provide specific, evidences. Okay. For whatever you talk, make sure that whatever you are speaking there, it should be evidence based. Okay. Demonstrate your confidence without over promising or without over jumping with the actual things. Okay, this is very important when it comes to feasibility and viability, right? Because in the feasibility and viability slide, you are talking about the technicalities, you are talking about the risks, you are talking about the budgets, costs, and also you're talking about the business. The four aspects you are talking here. So guys, you should be very, very careful when you are talking about all these aspects. Okay, so let us take the case study again back. Okay, what is the feasibility analysis I did for this is the technical feasibility is, since I'm using IBM Quizbit, okay, it provides ready APIs. So no need to build everything from the scratch. Okay, if I want to develop a, agri app or agri spraying drone, I no need to develop a drone first. Okay, drone is already available in the market. Buy the drone and then mitigate it so that program it in such a way that it can be used as an application so that it can spray the thing. Okay. Then financial feasibility. The initial cloud cost is 1.2 lakh for pilot. Now 1.2 lakh, do you have the 1.2 lakh for your team? No, right? Then what you will do? For innovators and startups, I think your incubation center will have free cloud access to most of the cloud services providers. AWS, I think incubation centers can give, and DigitalOcean they can give. Okay, and also you can focus on other tools as well. Okay, and if your incubation center or institution is not providing, try with some government partnerships whether they can give you this finance or the cloud credentials for this. Okay, then operational feasibility. Okay, so mobile app tested in 2 villages with 70% successful adoption. Okay, when you are operating your solution, what is the adoption rate? Whether your customers are successfully taking it and using it, or are there any challenges for that? Okay, now I also listed the challenges and risks here. Okay, the first challenge is the infra cost. The cloud cost and the computer cost, all these things. Then the second challenge is data availability. The third thing is farmer adaptability. That's what I'm talking about. Here we are talking about the finance, we are talking about the business, we are talking about the solution, how you are implementing. Okay. So now what is the impact? I mean, impact in the sense, does it slow down your operations, or what it will impact? For quantum infra cost, the impact is it is very high operational expenses for students like you. Now, what you will do, you have to approach incubation centers or governments for getting this, quantum infra. And then data availability. So very, very limited rural data sets are available. Now you have to build on your own. Farmer adoption, because we have low literacy, low tech literacy. So there will be some challenges in adapting this solution to the farmers. Now, how you will mitigate this? Are you coming up with, student-based communities so that students can go reach out to farmers and help them? How you are doing this? This is the another case study that I'm putting for feasibility and viability slide for my problem statement. Again, I'm keeping here. Okay. So now when it comes to the impact and benefits slide, okay, what the students has to prepare and talk about when you are presenting, what is the potential impact that student or your solution is giving? Okay, so who will benefit from this? So define your target audience. That's what the customer segment. You have to build your customer persona, customer segment persona. What is the age? What is the gender? What is the education? And what is their, occupation? Okay, where the geographical location of their, okay, like this, you have to prepare their persona first. There is a separate demographic, form you have to prepare, and you should narrow down your customer segments. Okay, so quantify impact if possible. Okay, whatever the impact you are putting in here, you should make sure that put it in numbers, put it in data. Okay, so here I'm just giving you an example. My solution can reduce manual processing time by 40%. Either you can reduce the time, you can give the money, or you can reduce the money, you can save the money. That's what, okay. Or any other resources you can, you are reducing human resource or time, whatever it is. Okay. What is the benefit, potential benefit you are giving? And apart from that, what is the impact, social benefits, and economic benefits, environmental and ethical benefits you are providing with your solution. You should be very, very clear with these benefits and impact you are creating. For my thing, I'm giving you one example, two of my startups. Okay, so one is a software engineer with 11 years of experience. He came back to Anantapur. Now he is working with 15,000 plus farmers here in Anantapur, and he is providing market access to all the produce and also the value added products from agriculture and food. That's what he is doing, and that means with his one startup he is providing and he is impacting more than 15,000 farmers. That's what the benefit he is giving. And there is another startup. She is from Kolhapur, and she is also doing the same thing. She is doctorate in Australia, and she came back and she is working on jaggery-based value chain. And now she reduced the total value chain, and she is working with more than 10,000 plus farmers in Kolhapur. Okay, she is impacting 10,000 plus farmers. Okay, and there is another startup who is reducing the impact that comes to environment through banana waste. Okay, so like this, you have to make sure that what are the social, economic, and environmental benefits and impact you are creating through your solution. Okay, and make sure that if it is with number based, then definitely it's a wonderful, tick mark, I should say. Right. So then things to keep in mind when you are presenting this. So always connect impact back to the original problem. How your impact and the solution, okay, and the solution solving that problem is creating this impact. Okay, whenever you are presenting, make sure that you are putting these connections. Okay, use simple metrics, the data, okay, the comparisons with the existing solutions. Okay, and what is the before and after visualizations. Okay, you should keep that. So ఇప్పుడు మనకి reels, I mean, so now we're getting these reels also. Okay, so the 10 years challenge and 15 years challenge, similar to that you should come up. Okay, so before this is the situation and after this is the situation. Okay, so then show the bigger picture. Okay, so make sure that why your idea matters nationally or globally. Okay, if it is environmental, it is global, I should say. Okay, so keep this in mind when you are presenting this impact and benefits slide. Then coming to this, one second, yeah. Coming to the case study example that I'm putting here, the potential impact on the target audience. Who are my target audience? The target audience are farmers, and the geographical location is initially it is Andhra Pradesh I'm taking. Okay, so I'm impacting farmers in Andhra Pradesh, and here I should mention I am impacting more than 1.5 crore farmers in Andhra Pradesh. I'm just putting data here. Okay, so then I'm also impacting agriculture transporters, the boleros, aichers, lorries, okay, and the local wholesalers and retailers. I'm impacting these. So I should say I'm impacting more than 10,000 plus transporters and 1 lakh plus local wholesalers and retailers with my solution. You should mention that way. The benefits. See, whatever I'm telling, all the data and the numbers, you should research and put that number. Don't just put it randomly. Okay. So, and whatever the number you are putting, and you should put that reference and the data where you are extracted that data in the reference slide. Okay. And put that number, the reference number here. Then coming to the benefits, the social impact. What is the social impact I am giving to the farmers? Farmers can decide what to sell, when to sell, and where to sell without any exploitation. Okay, that is the social impact I am giving. So more knowledge, more forecasting I am giving here to the farmers. And the economic impact is I am expected to increase farmer profits by 25% within one season. Okay. And then environmental impact is I'm reducing food waste by 40% because of I'm using optimized logistics here in my solution. Then the scalability can expand across India, not only in Andhra Pradesh, and can benefit more than 1.2 crore small scale farmers. When I say small scale farmers, who is having 3 acres, 5 acres kind of thing. Okay. And before and after visualization, if I say the current scenario is 30% crop waste due to delays, with agri-Q chain less than 5% waste. The current scenario, if you see, no real-time price data, it is available. Now with agri-Q chain, we have live price forecasts. So with current scenario, unoptimized routes for transporters, and with agri-Q chains, quantum optimized routes we are providing here. Okay. So, and also I'm putting here the summary table, what you have to do for each and every slide. For slide 1, for idea slide, what to prepare. So prepare about the problem, solution and uniqueness. Okay. Then what you should talk, it should be simple. Make sure that you are putting a lot of visuals, and also make sure that it is very inspiring with your data. Then coming to the technical approach slide, okay, make sure that you are putting the tech stack here, process, flowchart, demo plan, if possible, demo plan. Okay. If possible, you can bring the demo plan and you can demonstrate your solution also. Then coming to what you have to present, show why tech was chosen, why this technology or this resources was chosen. Then coming to the feasibility slide, the viability risks mitigation, you have to prepare and be realistic and make sure that it is data driven. And the impact slide, benefits, reach, before and after visuals, you have to put it here. Then very important thing is quantify the data and connect emotionally with the total story. Make sure that whatever you are presenting, starting from slide 1 to slide 7, okay, and your preparation, your photos, your visualization, it should be more realistic and data driven. If you are not doing that, then jury will easily identify whether you did work or not. Okay, guys, this is a great opportunity, and whatever the slides I am putting here, this is your life lesson. Okay, you can take it out and you can use it for any hackathon. Okay, including Smart India Hackathon. And of course, our Amaravati Quantum Valley Hackathon is one of its kind. I think the students got a wonderful opportunity. I think APSHI has doing a wonderful job. I think no other state government is doing this. So now we are at the fag end. Now what we have to do? Yesterday I'm talking to Anil Garu, and Anil Garu mentioned that, okay, sir, further what we are doing is we are connecting these quantum, students or enthusiasts to the top MNCs like Infosys, TCS, so that they can work with them closely. Okay, these are the further steps after this. And then, so this is our incubation center at Anantapur. Okay. So I request any of the institution or students can come down to Anantapur, visit our incubation center. You can interact with our startups and innovators. Okay. And most of my academic partners also joined this show. Okay. So that's all from my side. Thank you very much. Okay. Thank you very much, APSHI, for giving us this wonderful opportunity in reaching out. I think I should say this is mega boot camp. Okay, reaching out more number of innovators, futuristic innovators. Okay, thank you very much, sir, Anil sir, and APSHI chairman.
Thank you, sir. Thank you very much for an elaborate session on the nitty-gritties of the submission of problem statements. I think everybody got all the information, the flow of the hackathon also. Now I may request any SPOC or any student, please unmute your mic and you can clarify your doubt with the today's resource person, Dr. Chandramouli Garu. Definitely it will benefit everybody. And also, first of all, I would like to congratulate all the students because you are the first advocates for this quantum computing and quantum technologies. I wish that definitely if you travel in this journey, definitely you will all be placed in Amravati Quantum Valley itself. That is the potential of our Amravati Quantum Valley. Sir, any SPOC from the participants or any student can ask any doubts. Please unmute yourself.
Sorry, we are unable to hear your voice.
Sir, please you introduce yourself and from which campus you are speaking.
Dr. Mauli, am I audible?
Yeah, you're audible.
Yes, I am Professor Devaprasad Raju from ANDHRA University. For the better understanding and for the better preparation of the students' PPT, it is better to share in this Zoom itself, your PPT presentation.
Yes, sir.
Is it?
Definitely, I will share in group, sir. No issue.
Okay.
If you are in the group, you will find it.
Okay, sir.
Okay. Any other questions? Okay. First of all, I'd like to, use some sign language. If the session is good, can you please, raise your hands? If the session is good, please understand. If there are any issues, you can raise your hands. Okay. Is the session good? Is the session good? Is it understandable? Yeah, good. More number of high fives I am getting. Thank you.
Yeah, it's super good, sir.
Thank you. I think this is a very good opportunity for me as well.
Excuse me, sir. Sir.
Please,
Yeah.
please.
Sir, I'm Omkar from Aditya Degree College, Anakapalli, computer science lecturer. For Quantum Valley Hackathon, you have provided some problem statements, no, sir?
Yes.
What we have to provide solutions for that, or we have to provide some ideas related to the hackathon?
You have to provide the solutions actually.
Solutions for the
Okay.
problem.
Initially it is ideas. Then we on the go. Actually, the process you have to come up with solutions.
Okay, sir.
Yeah.
First, we have to provide the presentation idea.
Yeah.
Then what about this, sir? You have said in the meeting about ideas, impact on society.
See, there will be an internal hackathon initially. Okay.
Okay.
So in that internal hackathon, I think your SPOC will brief you the procedure, the total procedure of hackathon. Okay.
Okay. It's based on complete SPOC's choice, sir.
No,
Spock's choice.
I think Anil Garu has to, answer this.
No, sir, it is not. SPOs, we have given 10 problem statements because our Honorable CM Garu and Chairperson Akshay, they have come up with an idea of creating an awareness among all the students and faculty. So we have chosen only for this quantum technology related problem statements, 10 statements. So you have to work on that and you have to submit your idea and you have to give a solution and also proof of concept. So next 3 sessions will be specifically on these problem statements. Don't worry. Actually, the bootcamp is to handhold all of you to create awareness and to give you a direction.
Okay, sir. Internal hackathon should be conducted on the ideas that should be impact on society.
Exactly.
Good afternoon, sir.
Yes, please.
Okay.
Am I audible, sir?
Audible.
Sir, basically we belong to agriculture and horticulture background. We are unaware of this coding, etc. So how could we prove the problem and how can we create a prototype, sir? Can you please explain?
Sir, these will be dealt by next 3 resource persons because they are technical experts. But I have shared some cloud, free clouds, IBM cloud also. So if you have any algorithm, you have any idea, you can use that algorithm. Actually, some softwares like Python is required. So maybe if you know Python or you may not aware of it, your friends or your colleagues, because we have arranged a team, each team will be 6 members. Otherwise, you can also discuss with others. You can use that software and so that you can submit an idea and create an algorithm so that you will get a beautiful result. Not only that, you can also use AI platform also. Anyway, the next 3 sessions will be dealing on these issues, right, sir?
Okay, sir. Thank you, sir.
Excuse me,
Good
sir.
afternoon, sir.
Good afternoon, sir. This is Muralidhar from ANDHRA Degree College, Anakapalli, sir. Actually, could you please send any video related to this, sir, regarding better clarity for and all?
Sir, already YouTube is shared. You can watch anytime. YouTube is also already shared.
Okay, sir. Thank you.
Sir, good
Thank you, sir.
afternoon, sir. I'm a student from Vidyajyoti Institute of Technology from Hyderabad. We actually have a doubt. That is, sir, there are 10 problem statements which is there in website. Can we choose other problem statements with the same domain on our own to make it unique?
No, madam. These 10 statements are identified and you have to work on this.
Okay, sir. Thank you.
Good afternoon, sir. My doubt is there any roadmap available by what time we need to develop the prototype? And second thing is, one problem statement can be chosen by how many teams?
That is up to you, sir. There is the roadmap is there in the website. The dates when the internal hackathon must be done, when the semi-final will be done, when the final will be done. Everything is on your website. Any teams can choose the problem statement, but we will pick only first one, the topper.
Good morning, sir. This is FCOC from GMR Institute of Technology. So there are 10 problem statements given in the Velocity Quantum Value Hackathon, but the problem statements are directly only 1 or 2 sentences. Normally in hackathons, problem statement contains some of the requirements and other things. Is there any elaborate way of giving the problem statements?
Sir, tomorrow session it will be elaborated.
Thank you. Thank you.
But there is a description of problem statement in website also. You can go through the description. Anyway, tomorrow it will be dealt very elaborately.
Right.
Hello. Yes. Good morning, sir. Yeah. Actually, from your side, can you provide any real-time data set for working on that? Like what you have said right now, agriculture minus supply management. So from your end, if you provide a data set, real-time data set, that would be helpful as actually for implementation part.
No, I think the research you have to do, that's the whole idea.
Yeah,
Okay.
I understand. See, thing is that should be related to some society, right? So if you provide the real time, so when I search for a website, so we'll get many data sets actually. So we are getting many data sets from your incubation center. If you have any real-time data set, if for whatever the problems that you have provided, 10 problem statements you have given. From your end, if you provide any real-time data set, that actually better actually. That is my actually perception.
No,
So,
understood.
yeah.
But the whole thing is when we see this innovation landscape, the problem statement and the market research, you no need to do all these things. Okay, because the problem statement is already there. The only thing what we have to do is we have to bring up the technology part, how you are implementing the quantum algorithms and integrating artificial intelligence to the solution part, and then you are presenting here in the hackathon. Okay, there are total 10 problem statements. For identifying the right problem and validating the problem, you need market research. But in hackathons, we don't bother about these things because problem statements are already available. Okay.
No, I am not. My actually thing is not in the hackathon, not in respect of the hackathon. So
Okay.
once hackathon is clear, then we are going for marketizing. So at
Definitely
that
we'll
moment,
provide at that time. Definitely we'll provide more support at that time.
Yeah, at that moment, I think we show the work, like everything. If it is a real time related to or close to society, then it would be better actually.
Yeah,
So
perfect.
that's
We
my
can help you
suggestion
in that
actually.
way. We can help
Yeah.
you in that way.
Only for those problem statements.
Understood.
So it's good for actually we can also focus on exact real-time data set.
See, the whole idea of this hackathon is how we can bring up more quantum innovators and startups. Okay, if after this hackathon we will get more innovators, and we will also see how we can handhold them so that they can become startup enterprises. Okay,
Yes,
and bring
yes.
more value and impact. That's where I think incubation center should involve, and we should handhold the innovators and startups. Definitely, APSHI and incubation centers combinedly work together. So we will see how we can give more handholding support to you.
And second issue, sir, from institute level. So whatever, when we are finding for BTech students for this hackathon, so as per your timeline, actually we are unable to find, because this is not an easy to start actually initiate from the BTech level. So why you not included the like MTech or PhD level? That because some people already started research on quantum machine learning. So if you are included like this guy, PG level or PhD level, so that would be, I think it's better actually. I'm not against the PTech, but PTech is the initial stage right now. So within the whatever the timeline that you have provided, it is very tough to, I mean, gear up for them. So at this timeline. So this is the difficulty we are finding actually at UG level.
Sir, okay, sir. Because the next speaker is waiting.
No issue, no issue.
So
This is
we can,
one issue we are facing actually while at the institute level.
we can resolve, sir.
Yeah.
On behalf of APSHI, I profusely thank today's resource person, the first resource person, Dr. Chandramouli Garu. Sir, very thankful to you for your wonderful presentation. And as many of our spokes and students are very eager, maybe they will connect to you directly.
Definitely.
And as Chandramouli Garu invited all of you, you can also visit his center. He is doing a lot of work in this innovation and startups field. And he can also connect some bankers also, even the investors like these things. So as per the vision of our Honorable CM Garu, every student should become entrepreneur. So this is the biggest platform I think I ever see in the state, I think. Thank you, sir. Thank you very much. Now I may request. Thank you, sir. Now I may request Dr. Indrakshi, madam. Are you there, madam?
Yes, am I audible?
Yeah, madam. Welcome, madam. Before commencing the session, I would like to introduce you to the participants. So, madam, there are almost 20,000 plus students are there. They are watching live, and almost 197 single point of contact faculty members are also there. So this is the biggest ever boot camp, I think, online. For this wonderful Amravati Quantum Valley Hackathon, the preparatory phase of boot camp, you are being. Thank you very much for accepting our invitation. Professor Indrakshi Roy Chaudhary, madam, she has done wonderful work in particularly the quantum aspect. So her professional experience is now she is working as assistant professor at BITS Pilani and also KK Birla Goa campus. And earlier, she has a lot of research to do. It has almost a 12-page CV. I cannot read, madam. Sorry for this because time is very less. But I can post it to the benefit of students also. So she is a postdoctoral research associate in University of Maryland, College Park, USA. And her research assistant professorship is at Incubator of Quantum Simulations, University of Washington, Seattle, USA. He has undertaken wonderful projects across the globe. Some of the projects I would like to read out for the benefit of the SPOC and also students. Under the title Quantum Computation Application Team in the year 2019 to 21 at USA, she has developed a quantum computing algorithms and applications and performed collaborative research, published articles. And another important project is towards quantum simulating non-abelian gauge theories and also real-time dynamics and quarks and gluons, a quantum simulation approach. The quantum simulation and quantum information with the trapped Rydberg atoms gateway to a new technological era. The development of algorithms for simulating strongly correlated systems on hybrid classical quantum architecture. And the list goes on. So to her credit, she has hundreds of publications in a peer-reviewed international journals. And she has also got a Serb Government of India project that is Startup Research Grant as a principal investigator amounting 20 lakhs, and also another project served Government of India a core research grant for 3 years. It is amounting 30 lakhs, and also research initiation grant, all types of research grants from SERB DST, Madam has worked out. And she also submitted quantum computing application development QCAD. There are so many papers are there. I may not able to read all these things because of the scarcity of the time. Now the floor is open for you, madam. I welcome you, and you please inspire our young teams, because there are more than 20,000 students are there, and we may call them as quantum advocates and quantum enthusiasts. Now they are willing to work with the Amaravati Quantum Valley by the time 1/1/2026 it commences with the 156 qubit IBM mission. Thank you, madam. Welcome.
Thank you very much, Dr. Anil Kumar, and thank you for this elaborate introduction. So let me try to share my screen. Let me know if my screen is visible. Is it visible?
Yes, madam. Yes, madam. Visible.
And okay, I cannot see it. Yeah. Just let me know if the screen is in the full screen mode.
Full screen, yes, madam. Full screen.
Okay, great. Thank you very much. Thanks to Government of Andhra Pradesh and ANDHRA for taking this wonderful initiative, creating this Quantum Valley, which is a pioneering, it definitely be a pioneer worldwide, and also taking a lot of initiative in spreading quantum education, quantum awareness, starting from school, college level. So today I will not take much time, but I will just try to motivate students a bit, and we'll try to explain what this is all about. So if you are a physics student, you must have gone through quantum mechanics course as a part of your curriculum. Now, how is that even related to this bigger picture or the work that will be happening in Amaravati Quantum Valley and so on? So, as we stand now, we know quantum mechanics has been created 100 years back. So there has been continuous work for these 100 years to describe the nature which is inherently quantum mechanics. So what is quantum mechanics? To me, whatever we see around is actually quantum mechanics, that the nature is governed by quantum mechanics. Maybe we don't see its effects at certain scales in our daily lives, but it is always there as the underlying principle behind whatever we are even seeing, whatever we are doing and all. But we don't understand that fully. There is a lot of mysteries in nature that we don't understand. And that's the point where understanding of quantum mechanics helps that, okay, maybe we can understand at more and more depth our nature. And using that, a tool of quantum mechanics, that's the most fascinating part. So what is a quantum mechanics? As you say, the term is mechanics. From your high school, from your class 12, you know what mechanics is. It's motion of a particle followed by Newton's law, which has been there for over 300 years. So what you do there, let's say you know there is certain force which is being applied to a particle, and that particle moves in a path, has certain values of acceleration, velocity, and those are the quantities you calculate. And you develop engineering aspect based on that, be it mechanical engineering or anything else. That is based on what is the classical mechanical rule of motion of particles. Now, how is quantum mechanics, the classical to quantum, the system remains, let's say, a mechanical system. So you still want to ask the same question, that I have a particle, I'm applying this force maybe, I want to see where the particle will be after a certain time, with what velocity it will move. Those are some basic questions that you may aim to ask. And even asking those questions become non-trivial when it comes to quantum mechanics. So quantum mechanics, as per the modern understanding, is based on a set of postulates or assumptions which are all very much counterintuitive. For example, when you think of a classical particle, you ask the question, where is the particle at certain time? What is its velocity? What is its acceleration? And you find those answers by doing some measurements. You calculate the position using a scale. You calculate its velocity using its position at two different times, calculate the time difference. So you need to make some measurements. Those are very basics to understanding what is happening to the particle. Now, if the particle is quantum mechanical, then the question becomes non-trivial. The question that you will have to ask, okay, how do I describe the particle at some time, at one particular point? What is the particle? That question is very non-trivial to answer. The postulates of quantum mechanics tells you the particle, the state of the particle is something like a vector. Vector is something that you have learned from your high school as well. You have a vector, you can imagine a three-dimensional vector in a three-dimensional space. You know you can add vectors by vector addition. Addition of two vectors gives you another vector. Certain physical quantities are vector. For example, velocity, force, those are vectors. A quantum mechanical state is similar to that. It is a vector. Is there any question? Okay, so let me proceed.
I request all the participants, please mute yourself. Yes, ma'am. Okay.
Describing a quantum mechanical system can only be done by mapping or imagining it to be a vector. And when you have a space containing many such vectors, you know that if you add two vectors, you get a third vector. And you can add them in all possible ways. You can take a linear combination of vectors that will give you another vector. So this is what you can be popularly familiar with, which is superposition principle in quantum mechanics. Quantum mechanical states can be superposition of many states. That is basically because they are vectorial in nature. So this is about some state. Then you want to make some measurements of the state. That is something again very much different from the classical world. So making a measurement in quantum mechanics is related to defining an observable, which is like an operator. So you have an operator, acts on a state, and it should give you another state. That is the job of measurement in quantum mechanics. Then something more funny happens. What is the outcome of the measurement? You take a state, you take an operator, anything physical that you want to measure has to be associated with certain operator. Now you make the measurement. What should you get? That becomes a completely random observation in quantum mechanics. You make an observation, you make a measurement, the outcome of the measurement, you will get some eigenvalue, something random, not very specific. So quantum mechanical measurements are not specific, or it cannot be deterministic. It's kind of probabilistic. So you make one measurement 1,000 times, you will get different outcomes. And every time, as soon as you make the measurement, the state on which you make the measurement, the state will be changed. So you prepare a quantum system, you prepare a state, you prepare a very sophisticated operator, you perform the measurement, do one measurement, you get one random value. And you cannot reproduce the same result by doing the same experiment. You repeat the same experiment second times, starting from a very new initial state, you will get a completely different value. That is what makes quantum experiment very, very complicated and expensive. That is why quantum systems. So right now, after this, whatever we are here now, the whole game of quantum computing or quantum hardware is developing a physical system which you can control. So you are making a physical system where you can tune what state I want to prepare. Those are the states known as qubits that is used in the conventional quantum computing setup, and you may have heard that thousands of times. So a qubit is a specific quantum states. If you take superposition of qubits, that's a complicated quantum state, and there can be infinite possibilities for some states. As you have been hearing that you will have a system of 156 qubit quantum computer. So you can think of that as a huge physical system where you have access to independent 156 two-level systems in mind, and you need to engineer the controls so that any measurement or observation you want to make is to be achieved by those. Those are the quantum gates that you often hear popularly, like the CNOT gates, rotation gates, blah, blah. Those are basically operators which acts on the quantum states and gives you certain outcomes. So this is the whole game of quantum hardware and controlling it. And the challenge, as you can already see, it's an extremely expensive, technologically advanced task, that how can you actually control a quantum system and make use of it. So right now, there are several technology giants who have succeeded to prepare such quantum systems in practice. This is a miracle that we now have quantum computers available with us. Now the next level of challenge is, how can you use this as a technology solution? And this journey has begun, and you are all listening to these talks today, and we will be starting to work on this soon. So you are all definitely part of this. And in Amravati, what we are going to have is a quantum valley, which will house this IBM quantum system, and quantum hackathon that we will have in near future is a step or a staircase to enter into this bigger world. This is the world of future, and you are just stepping into it. So as you can think of, what we are now deciding, it's a change of paradigm in terms of how computation works. We have all used classical computers. We all have a smartphone in our pocket now, and which is nothing but a computer. And that has evolved. Even when I was a child or of your age, I didn't have a computer in my pocket, but you have. So the technology has evolved so fast. So it's very interesting to look into the journey, how the classical computing evolved and how that has reached at a stage where we can just being able to even listen to my talk from across the country or even beyond. So there has been several generations of computer hardware that has evolved. If you can think of where are we now in terms of quantum computer, you maybe think of at most first generation or the boundary between first and second generation, where you might have seen classical computers of big room size systems. And right now, the IBM quantum computer that you will have, that's also a huge setup, which will never fit in your pocket in a smartphone right now. So we are at the very early stage of hardware development when it comes to when it comes to a computer. But we have had a lot of lessons from classical computing era. So classical computing evolved. It started with the Turing machine in 1940s, 30s, and it evolved to the current stage of supercomputers. What has happened in between is there has been layers of improvements, and it's only until 1970s or so where people started realizing that computers are of actual use. And scientific computing started happening using those computers and more. So if you just look at the journey, it is 1948 where the first computer program was written on, and it was run on a computer. So this analog of this in quantum era kind of happened maybe 5 or 6 years back, where an actual code was running on a computer. Then over time, the application development took place more, and when that only happened as hardware also progresses. Yeah, as I mentioned, it's around 1970s where computers became a reality. PCs appeared, supercomputer even started to be made, and then there was a boom and that happened because this microprocessor technology was developed. That made computing scale down, the chip became smaller and smaller, and then right now what we have been hearing a lot of times that computing is available over cloud. So right now we are living in the era of cloud computing and supercomputing. Even National Supercomputing Mission is already being launched and has produced supercomputers within India. So we are now entering at this stage when it comes to classical computer. And then the question obvious is, why are classical computing useful for? The high performance computing, HPC, is a word that you might have heard or you keep hearing. And you also hear certain aspects like data science. There are also fields which you may not be very familiar at this level, which are computational science. So for example, data science is a interplay of domain knowledge, where computer science will be used for engineering computer systems, and statistical analysis of that, incorporating machine learning and all. This creates the field of data science, where data can be used to advance the knowledge. Computer science or computational science is rather beyond data to understand computers for discoveries. So that has made huge progress over last many 2-3 decades, definitely even more. And HPC has applications beyond science, like in climate weather prediction, manufacturing, materials, transports, geoscience, finance. In health sector, there has been countless applications of computer. Now, the question is, where do we stand when we are at this change of paradigm? As I mentioned, you can almost no way connect what classical computing is and what quantum computing is, because quantum world is entirely different from classical world. So you will have to come up with new strategies, new computational strategies, and that's where the discoveries of quantum algorithms, etc., are very much important. It's not that you have something in classical, you just translate it to quantum. It's completely new. Then the question is it a competition between the classical computer or a quantum computer? Will be someday your friend will tell, okay, now I have a quantum smartphone in my pocket and mine is better than you. That day will never come for sure. Quantum computer is never a competitor for a classical computer. But what is this? It is a complementary tool, technology. There are a lot of roadblocks for classical computer. Even with the supercomputers, there exist many problems, real life problems, which cannot be solved in no way using a classical computer. And that is the point where quantum computer may help, and that is where the entire world is now exploring, whether quantum computer will be of help. This is of many use. Even the big giants like IBM, they are investing a lot of money in developing quantum hardware. That is expensive, but they also need to know what will be the uses of their machine, who will be their buyers. if they don't see buyers, they will definitely not build it just for fun or will not invest so much. So that is why at this point of time, it is really very important for a nation, for everyone to understand what will be the applications of quantum computer. What will it be used for? It will not be used as a replacement for your smartphone. Then why are we investing in that? And as I mentioned, quantum machine is very difficult to make, very difficult to control, very expensive. Then how can we use a combination of whatever classical computing we have, be it machine learning? Machine learning is something, AI/ML is something which has developed now, and it is of very great use for several problems. So how can you combine those classical computing outcomes with a small part of quantum computing as required to provide a most useful solution? And this gives a classical quantum symbiosis, which is sometimes referred as hybrid computing or hybrid approaches. And this is the way. You have no other way to go forward because quantum computers are difficult. So yeah, these are some of the pictures that you have seen a lot of times over internet, and it will come to your news feeds. These are the big giants, tech giants worldwide who are investing a lot in quantum computing and preparing state-of-the-art quantum computers. We have a national quantum mission in India, which is also working in the same direction, so that we can now say, yes, we have at least entered the quantum computation era. And we have the lesson from classical computing era that computing is even beyond data science. It is an aid of discovery, aid of welfare, and it requires to be used. So the question now is how quantum computing can be used for larger application and can be even applied for societal applications, as you have received a set of problem statements which include some of this. So summarizing what I said, quantum hardware is very much at its infancy, but we have the understanding from classical computing era so that we are now ready to identify the applications in quantum computing and to make progress towards that. It is not something that we will achieve in a day or two. It is a long process and we are part of it. We will have to make some progress in it. So yeah, this is kind of, I have already mentioned, the first task is identifying the applications. So this hackathon gives you that opportunity. It gives you a set of problem statements which has already been identified by experts. Now it is your role how you can take it forward. So how we'll have to do it? You will have to anyway map it to a language of quantum computing or a quantum mechanical system so that you can use the power of quantum mechanics to get advantage. That is what is known as quantum algorithm development. Then you will have to implement that algorithm using available hardware, being it IBM hardware or the hardware you will get in AWS. That will be facilitated at a later stage. And you will have to think of scaling. Here I mentioned one point that we identify this as our role. Who are us? Those of us, we are not really building a quantum computer. We are not doing an experiment like as IBM experimentalist researchers do. We are not building a hardware in this hackathon, but we are assuming we are given the hardware. How can we use it for applications? And this is the big visionary idea that famous physicist Richard Feynman had in 1981. He realized back more than 40 years back that our universe is quantum mechanical by nature and we don't understand most of it. So we need to find a way to use nature to understand nature. And that is where comes this quantum, the concept of quantum simulation. So what is kind of quantum simulation? Here, if you look at my slide, you will see that I have described two systems. One is a quantum system, which you want to understand. And here I call something as a quantum simulator. This is a system you can think of the IBM quantum computer, which will sit in Amravati, is this one, which is in your control. So you can control it, and whatever you are measuring from here, the outcome of the experiment, you are mapping that to say something about here, where this quantum system you can think of is a very complex protein that you don't understand, which is necessary to understand for a specific drug discovery. Which there is no other way to understand that system. You map it to your available quantum system, which is like an IBM quantum computer, and you understand it. And you map that knowledge here. This is what is known as quantum simulation. You simulate a quantum system by another quantum system. And this is a very useful or most useful quantum computing approach, which shows that there will definitely be an advantage because both are quantum inherently. So there are various quantum simulation platforms. You might have heard some of the names like neutral atoms, trapped ions, superconducting qubits as the IBM one, NMR qubits, photonic qubits, blah, blah. Each has their own technological stage of advancement with its weakness, strength, and usability. So those are the research part that you will have to do. You propose a solution, you will have to identify what kind of platform is more suitable for your solution. Yeah, let me skip most of this part. So this is what I called as a quantum simulator. Quantum simulator is basically analog of the early days of application-specific integrated circuits, which people used to have back in 70s or before that. Then comes the modern days PC, which is like called universal quantum computer, which can do any job. This is somewhere we are approaching, but we are yet to completely approach the Qiskit or the popular ones that you will find, which uses kind of a Python circuit in emulating a quantum system. There, the strategy is mostly based on universal quantum computer. So you make a universal gate that should be applicable for a wide class of systems, not very system specific. But there are also certain problems for which a specific system works in a superior manner that researchers are continuously working and exploring. So this concept of universal quantum computer is not even new, like you will see from 1970s. Is there any question? I think it's a matter of muting.
Please mute this person.
Yeah,
I request.
unmuted. So universal quantum computers, an example of that is the IBM quantum computer, although you can even use that as a simulator. Okay. So what is your role? As I mentioned, the whole thing starts with setting up a problem statement. And the problem statement has to be domain specific. For example, in the previous talk, you heard that a candidate problem statement comes from the agricultural domain. So identify the problem statement, then you will have to choose a certain computational strategy. You can choose digital quantum computer, analog quantum computer, which are like the simulators I have been mentioning, which is particularly useful for quantum chemistry problem that you have in your list of problems statements. And most of the cases, the problem statement will have to be hybrid. You will have to use HPC as well as the quantum processing unit, QPU, and then developing algorithm. Once you do that, you will have to focus on an improvement strategy. If it is just reproducing whatever you could do with classical computer, okay, it is fine. It is proving some proof of principle for quantum computer that it is capable of doing that. But quantum computation is expensive. So you may not really want to use it for some trivial problems, which you can anyway solve with a calculator, that's it, like adding two numbers. You are not going to use a quantum computers to add two numbers. So you will have to focus on an improvement strategy. The problem statement, where is the limitation of high performance computing and where is the promise of using quantum technology to yield certain improvement. This hackathon, it will be most useful for you if you maybe just focus on this part. That makes things really useful and it can be pursued even in future. Then you work out these improvement strategies, work out the enhancements, and that includes optimizing resources, error mitigation, blah, blah, all those techniques. And finally, you deliver the unique and improved solutions to the end users. And so in the previous talk, as you heard, that you may be setting up a business, setting up a startup at the end of the day, and you will be delivering some solutions, maybe to the government, to your clients. But these solutions are to be achieved via these few steps. So this hackathon starts from here. This is given to you. Your job is to do enough research to understand what path you choose and what is the improvement strategy that you can focus on. So it requires a lot of research work because this whole thing is a research topic. So it's your journey in research that begins here. Yeah, so let me skip. There has been a lot of research going on in this particular area, and this number of research works is expanding a lot. So you will find a lot of resources in internet. There are too many open access papers or even the papers on archive which you can access. You should sit down with your mentors, your professors in college, and to understand which one is suitable for you and proceed from there. So for example, here I flash a set of very highly cited famous papers which focuses on quantum simulation of many-body quantum systems. And what is that applied to? That's applied to discovery of new materials. Discovery of quantum chemistry algorithms lead to novel drug discoveries and even beyond. So the whole idea is how you understand how electrons behave inside a matter when they are strongly interacting with each other. Understanding that better will give you certain algorithms, and that will finally lead to quantum simulation for material discoveries. So the aim here is to do, so material discovery beyond whatever is happening right now worldwide. And the end users, of course, are material scientists, chemical engineers, and it will also lead to new science directions as well. Yeah, these are some of the material discoveries articles. What I personally work on is understanding fundamental particle physics. You know that whatever we see is consists of protons, neutrons, and electrons. So this nucleus, when a nucleus of a particle you focus on, that is created out of quarks and gluons. But we don't understand that fully. No one knows in the world why quarks are bound together to form a proton. That is an unsolved problem and is a Millennium Prize problem. No one knows that in this large-scale particle accelerators like LHC, the particles are moving and they are colliding with another particle, new particles are being discovered, but there is no strategy, computational strategy, which can tell you, okay, at this time, at this physical point, we will get this particle. So these predictions, which are absolutely important for all these large-scale sophisticated experiment. The tool for this prediction is absent even using largest supercomputers. So that is why the particle physics community, high energy physics community is solely relying on quantum computer to give that answer. And this is a very interesting idea that this computational research for particle physics was co-developed along with the hardware development of supercomputers. It started in late 70s, and even the early IBM computers were named after this QCD process as their processors. So this is a journey of co-developing science and co-developing computer architecture. I mentioned of Feynman. Feynman was a very much enthusiast of quantum architecture, and that connects these two communities closely. And right now, there are these unsolved problems which even these biggest supercomputers present in all the national lab in the US can't answer. So the question is whether quantum computer will be able to give the answer. So there has been a lot of research over the last 10, 12 years in these directions. And you will see plenty of papers in the archive and all, but still we are not very close to the final answer yet, and the journey continues. In my research group in our department, we are also seeking answer to one of such very big problem in the world. And we are also collaborating with worldwide researchers in this problem. Okay, so I will not go into details of that, but to summarize, quantum computing applications exist beyond scientific problems, such as there are applications which has been studied in great deal in finance. So tomorrow you will have a presentation from finance sector, I think, from Q Krishi. Rushikesh will be presenting the how quantum algorithm can yield better finance solutions, which is of utmost interest to banking companies and finance organization, fintech industry as such. So there are various problems, and that has been studied. Even this is a roadmap paper written by from Q Krishi as well, who will be presenting tomorrow and will give more detail of that. How quantum computing in finance is a very important, and one should focus on this use case seriously. I think there is a problem in that as well. If any of you have heard of solving Navier-Stokes equation or the understanding fluid dynamics problems, many of you, when you travel by air, you often face turbulence. And aircraft designing has to deal with that, how they actually deal with turbulence. So this understanding turbulence is an unsolved problem in nature. It is also another $1 million problem. So this $1 million Millennium Prize problems are all big candidates of quantum computing, because it's a new technology, and the aim is whether one can use these new technologies to give you answer. So quantum computing for fluid dynamic systems is of very much importance, but yet it is very little developed so far. So we are also starting to work on this. Many leading researchers worldwide is working on this. This is just a very big problem to think about. And not only that, there are even industries. For example, this is IBM, and this is a Tel Aviv-based startup, Classic, who are investing a lot in understanding performing quantum fluid dynamics. And there has been a lot of research work that is happening. Every day new papers are coming, new roadmaps are being set to these new research directions. I'm not sure if there is a problem on computational fluid dynamics in this bootcamp, but this is a very big problem to look for you in the future if you find it interesting. What you hear more common is machine learning and something called quantum machine learning. So here at this point, I must make you cautious that quantum machine learning is a kind of a metaphor. You should not use the word often. Rather, you can try to combine machine learning and quantum computing to provide you certain answer. Because machine learning always deals with a large number of data. And handling a large number of data leads to handling with a very large quantum systems and their complicated operations, which makes a lot of error in the data. So there is no proven way of maintaining a data set on a quantum computer or accessing a large data set on a quantum computer. So large data is not the natural thing to do use on quantum computer. For that, you have machine learning. But then there comes certain quantum inspired machine learning algorithms which utilizes some certain features of quantum systems to give an improved machine learning solutions. That is often used best. And there has been a lot of work going on in that direction as well, which you can also explore while coming up with your strategy for attacking the problem statement. Yeah. So to summarize whole thing, quantum computing is kind of an ecosystem. Quantum computers are capable of doing certain specific job, what I didn't cover at all, but it is also included in your set of problem statements, is quantum communication or cryptography, quantum cryptography related problems. And that is something government is very much aware of because they want to make all our data, all our banking sector quantum secure. So quantum cryptography is a very big applications which one must achieve in near future. And quantum computing can be used as a tool to understand whatever remain is still unsolved in nature and to answer the very big questions in science. Who are interested in quantum computing? For example, people like me from academia, we are interested from fundamental knowledge perspective. There is a lot of industry who are interested to get advanced quantum solutions. For example, as I mentioned, finance, drug discovery, agriculture, and combining AI, ML. Most importantly, the quantum hardware developers, they are also interested to know what will be the outcome of this quantum system, outcome of developing these complicated quantum computers. So to build this complete ecosystem, of course, we need to overcome certain expertise gap when it comes to quantum. So right now we were doing your BTech degree, maybe some of you are doing MTech in college. You are learning various other topics. So this is the time for you to at least think how your problem will be connected to certain quantum computing applications or may actually gain from quantum computing, because it may not be the case that each and every one of you will be doing a quantum computing, hardcore quantum computing in future, but still you can contribute to the ecosystem as a domain expert, as a collaborator with a quantum scientist to make the translation, how your problem of interest is mapped to a quantum mechanical system which can be implemented on a quantum hardware. So for that, I think a lot of work is going on in this country right now. A lot of interdisciplinary conversation, discussion, training program, academia industry partnerships, designing programs like minor degrees, MTech degrees, and also BTech degrees in quantum science and technology is happening. And you are all here to participate and enjoy this Amravati Quantum Valley Hackathon, which I feel is a very important event for world. So you are aware of what are the objectives of this hackathon. Just I want to mention something that this is being a hackathon, this is a fast-paced platform. You will have to deliver within certain time limit, but this also the topic is a bit difficult. So practically speaking, delivering something by next 2 weeks, it would bring you a Nobel Prize. But that is too high for us to imagine that we will be achieving that. So rather, what the focus should be that you are learning something. So you are building something, you are learning something, and you are sharing the knowledge. A team from your college who will participate in this hackathon may go back and tell other students in the college, then see, this is the excitement I felt, and you may also find this exciting, you may join. As Dr. Anil Kumar mentioned, that having a quantum valley would require to have a huge workforce. So the workforce need to be aware of what quantum at all is. So the purpose of this hackathon is to learn, to share knowledge, and focus on innovation. As I mentioned, it is not something traditional. You will have to come up with drastically different ideas. So you start with a very simple thing that you have control with, and you document your journey, how you are thinking of making even a tiny advancement to this. What you think can be useful. Maybe it is not implementable right away, but maybe after 5 years it can be implementable. So document your ideas, start doing research on this topic, and of course think what you want to achieve. Not like I know this tool, I know Python or I know C++, I know Fortran, and I will start coding. That is the second part. Rather, the first part is what is the problem that you want to do, and for that, what you need to learn. You should be ready to learn many different new things in this course of action. Okay, so with that, yeah, these are the set of problem statements. It is available with you. Please go through it. Search over internet on each topic to understand which one you can actually address, you can proceed with. And then take the decision, make your problem statement, make your proposal slide. Okay, with that, I would just say that this hackathon is less of a winning, but about a beginning, connecting and collaborating for the future of technology. Thank you so much for listening. Am I still audible?
Yeah, yes, ma'am.
Hello?
Yeah, it's audible, madam. I guess, sorry.
Yeah. Okay, so if you have any questions, you can write me an email. My email address was flashed at the last slide. Yeah, if you want to see it again, I'm flashing it again. This is my email address.
Good afternoon, madam.
Yes. Hello, good afternoon.
We are from Amrita Vishwavidyapeetham Amravati campus. So
Nice.
the 10 problems are given, 10 problem statements are given. Whether our student has to use the same problem statements or a little bit change they can do and they can work on it.
I think it was mentioned during the last question answer session that the exactly same problem statements needs to be used.
Oh. Okay, madam. Thank you.
Good afternoon, madam.
Good afternoon.
Madam, can you provide the full papers of that research? Because we are unable to download the papers now. Can you provide at least 2 or 3 papers for us?
The papers you can really find in archive. So you first stick to what is the problem statement. I can even tell you, even AI can help you to find the references.
Literature related papers you can provide, madam. Students are very interested for that.
Yeah.
Full papers if you are provide, they will read and then can understand what the literature, what actually happened in the quantum. They will know about it.
Yeah. So I think the hackathon, this program, I think Dr. Anil Kumar may emphasize they are going to have some mentors, right? Who will from industry partners and all. So they will help with guiding through the process. I'm sure that if that is not planned, that is something that needs to be planned. How the mentors will guide the students through this process.
Good afternoon. You said in your presentation, addition of two vectors will produce third vector. Can it possible?
Sorry, I missed your.
Work with numbers also? If we add two numbers, can we get a vector?
So you mean to say that this whether the space of natural
Medicine.
numbers is a vector space or not? Yeah. So for example, while doing quantum mechanics, you all have, if you have done a quantum mechanics course, you have done in terms of wave functions. The wave function is a function which gives you a number. For certain cases, you will find a matrix corresponds to a vector, kind of a column vector. So you can add two column vectors, you can get another column vector. That's a classic example of adding two vectors and getting a third vector. So I would always say you understand vectors by its components. You are given a vector, you choose a coordinate system and you find the components along the coordinate system. And those are the numbers that you measure in the real experiment. So the whole idea is connected to that.
Good afternoon, madam.
Good afternoon. I can't hear.
In while modeling any problem, when we find the solution with machine learning and quantum analysis, if the results are not same, then what do we do?
So this is,
or how do we justify?
this is something that you even expect, because the quantum hardware that you even get access to, that contains a lot of error. And the individual steps of controlling introduces a lot of error. So many a times the researchers face this scenario that what is the outcome of for an actual experiment, quantum experiment is far away from expectation. Then there exist certain error mitigation strategies, and those have to be developed or decided based upon the hardware that you are using, what kind of errors you are facing, and it is very problem specific as well as hardware specific. So with the maximal use of these error mitigation strategies, you can only think of connecting or interpreting what is the outcome of your result.
Okay, madam. And one more doubt. When I am executing on the IBM real computer, so using CRN and all, so even though I change machine, sometimes I'm not getting output. It is taking a long time. Even though I wait, I'm not getting result.
Yeah,
So
these are the limitations.
in those situations, can we find any alternative?
So the best way to guess something is to use the IBM emulators, like the Qiskit one, which is not on actual hardware, but you have free access to that, and you can use model errors, etc., to get realistic results from these emulators, IBM Qiskit emulators. But actual hardware is very difficult to access, very difficult to interpret the results, and so on. So these are the challenges. Yeah.
Yes, madam.
These are
So
the
if we take subscription, can we get result fast?
This
Or nothing,
subscription,
that's
I
what?
can say this is extremely expensive. If only government offers a subscription, we can go through that. You know, this rate is like for per minute,
Per minute, 56
US dollar. So
okay,
this is
result
expensive. So there needs to be a lot of groundwork before actually accessing the hardware, because this is expensive.
Okay, madam. Thank you, madam. Your nice session is wonderful and excellent. Thank you very much.
so much. Okay, I think I'll have to leave now. It was
Okay,
very
thank you.
nice giving me the opportunity to speak.
My one last question.
Sure.
I'm Siddharth from Aditya Degree and PG Colleges, Kakinada.
Mhm.
So I just want to know if there is any access for IBM quantum experience software?
That you can have. IBM gives you 10 minutes of free access every month. So you can start working with this free access.
Okay, so I think that platform is also compatible to run AI models also. So what if we want to extend this for more than 10? Because I've seen the problem statements regarding fraud detection and others. So in order to run the models, because the data set will be a bit huge. So in that case, if we want to extend the time period, so is there any other source from the IBM?
So that is the whole point. You can only claim advantage when you have optimal use of quantum hardware as well. Not infinite use of quantum hardware will give you advantage. So these are the all different small strategies that you will have to work on in this hackathon.
Okay.
Good afternoon, madam.
Thank you, ma'am.
One last question, madam. I'm Dr. M. Padmavati from KVR Government Degree College, Kurnool.
Hello, nice to meet you.
Nice to meet you, ma'am. And I would like to ask a question that actually quantum technology is a multidisciplinary course which includes mathematics, physics, and computer science. My question is how to connect these quantum mechanics concepts to linear algebra. Actually, you told now in quantum.
This is the first point that I mentioned. If you look at my first slide, I can share my slides as well. This is the first thing I use in my quantum mechanics course that I'm teaching.
Actually, in-depth classes are required to connect these quantum mechanics concepts to.
So one need to have a full semester long at least quantum mechanics course to understand. But linear algebra is the underlying mathematics of quantum mechanics.
But they are not. They interconnection should be.
Yeah. It is very much connected, and that is what one need to explore.
We know linear algebra, but that connection to interconnect these.
So you please feel free to write to me. I will give you reference to textbooks, which there are very nice textbooks available. Which even modern textbooks published just last year, where you can get this very nice connections, and quantum mechanics can be made of real practical use.
Okay, thank you, ma'am.
Good afternoon, ma'am.
I guess I'll have to leave now. I'm so sorry.
Thank you very much, madam. Thank you for sparing your valuable time. And it's a very exciting disclosure from your side. And I think all our students got excitement and they will get benefited. Thank you very much, madam.
Okay, thank you so much. Bye.
Thank you, madam. Okay. I request all the SPOCs and all the students. I would like to say one thing. First of all, I want to congratulate all of you because you are connected to quantum technologies. During my post-graduation days, there is a problem called Y2K. Why I am mentioning this Y2K? At that time, whoever connected with the Y2K, he need not be a computer science background student. Many students, even from BA, BCom background, they learned the COBOL, they went to US, and now they are the big names in the US software market. So this is also on the similar line. If you connect with this quantum computing, quantum technologies, you will all get into the Amravati Quantum Valley opportunity. So this is the one thing I would like to mention, because it is not a new science, it is 100 years old science. So kindly connect with this. We have given, to encourage you all, we have given this very basic level of problem statements. These are very basic level. Only last two statements are somewhat mid-level statements. So you can use the IBM Cloud also. I have shared all the links in the group. With this IBM Cloud also, you can do everything. So this is what I would like to bring to your notice. And once again, I thank you all. And tomorrow, kindly join by 1:30 p.m. tomorrow. The people who are really working on this, actually the people who designed these problem statements will be delivering. Those sessions will be very much useful for you, and you can easily tackle these problem statements. And our expectation is by the time this quantum mission established in the Amravati Quantum Valley, you want to produce at least 100 use cases. So whoever can bring the best solution, they will be placed in the Amravati Quantum Valley. So this is a challenge. And this is also an incentive offered by AP State Council of Higher Education to you all students. So please spread the message and be quantum enthusiasts and be quantum advocates. Sir, any issues related to hackathon, you can please interact. There are 5 regional semi-final regional POC centers, as I mentioned earlier. That is Gayatri Vidya Parishad Visakhapatnam, SRKR Bhimavaram, and also Dhanekula, Vijayawada, and JNTU Anantapuram, and Sri Padmavati Mahila University. So these are 5 centers, regional centers. For any clarification, any doubts, you can approach them, or else you can post it in our group, Amravati Quantum Valley group. Also, we are here to help you. And it is a beginning. It is a beginning. We want to encourage you all to bring into this quantum momentum and to make our state as a quantum state. This is our wish. Now the floor is open for the audience. Anyone can interact with us. Sir, I would like to one by one. There are 5 centers. Madam, Dr. Anuradha, madam, from Gayatri Vidya Parishad, do you have anything to say? I would like to ask all the regional coordinators, SRKR Ravi Kiran Verma garu, and also Dhanekula College Madhu Ravi garu, and also Professor Suma Bindu garu, and also Ajay Suri Kumar. Sir, would you like to say anything?
Excuse me, sir. I have a small question.
Yes, sir.
I'm Siddharth from Aditya Degree College and PG College again. So what is the evaluation criteria, like on what parameters the projects are being assessed at different levels?
Sir, everything is on our website. I think there are guidelines. You have to read the guidelines. So each problem statement, we have total 10 problem statements are there. So best of the best, you have to entrust this to expert. So even during internal hackathon also, you have to involve some experts for this internal hackathon as a jury. Then they will select the best one. Those best, out of the best one, only 1 and 2 will be from each college. Only 2 out of the 10 best teams, only 2 can be sent to semi-final. Even at the semi-final round also, there is a jury. They will filter out only the valid and the high impact projects will be considered for the semi-final evaluation. And after the semi-final evaluation, they will come, the only first winners will come to finalists. So again, at the final round, experts will be there even from industry, experts will be there. They will judge this. This is the criteria.
Thank you.
Yes, please, any other Bhimavaram SVCW? Prasad garu cheppandi.
Sir, if you are allowing only 2 batches, that is
Yes,
very
sir.
difficult to our college, sir, because roughly 70 teams are registered.
Whatever may be, sir, this is the guideline. Actually, I understand your query. Again, there is a special expert team is there. So they will evaluate all the projects and only the best of the best will be selected.
From our
So
side,
why you are allowing most of the students at your level is to encourage and to create awareness, not to sort out the finalists. This is the concept. So we would like to create awareness among all the faculty, all the students. That's why we are parallelly taking up a faculty development program for faculty, as well as the student awareness program in the terms of in hackathon as well as boot camps. This is the only idea.
okay, sir.
Sir, you can encourage your college, but only 2 teams will be selected because it will be a very huge number. And not only that, we are trying to filter out at least 100 use cases ultimately. So the the judgment will be very stringent with expert groups.
In website, we are mentioned 5 teams. That's why we are asking, sir.
5 teams you have to select for your college, sir. So for 5 teams, APSHE, on behalf of APSHE, our chairman, sir, will give appreciation certificates. Okay.
Okay, sir.
From out of
Good
5
afternoon, sir.
select the top 2 teams. Yes, madam.
Yes, sir. I am from Pune, DH Rajani College of Engineering.
Oh, great, madam.
So,
You are welcome.
Kiran Patil.
Yeah, please. Please.
Sir, I want to ask, you have mentioned only 5 teams. So, only 5 teams are going to register, right?
No,
And
no, no.
after, yes?
Let me tell you once again. You can involve any number of teams at your level.
Okay.
So out of these teams, you have to select top 5 teams.
Okay.
And for the top 5 teams, we will give appreciation certificate. But you have
Okay.
to send top 2 teams to the semi-final round. That is the process.
Okay. And for the internal hackathon, it is compulsory to take any external jury from our side.
Yeah, madam. You have to take. You have to take.
Yes. And for the internal hackathon, only idea presentation is there, right, sir?
Idea presentation and even the POC should be there.
Sorry,
Proof of
sir?
concept. Proof of concept
Proof.
must be there. Yes.
Okay, proof of concept. Okay. Thank you so much, sir, for your guidance.
Madam, you are welcome from Pune, Maharashtra. I think 2-3 teams are there.
Yes,
And
sir. I also want to know, sir, regional.
And for you, we will arrange online session.
Okay, online.
You need not come to semi-final round, but if you qualify in the semi-final round, you have to come to Amravati for physical round.
Okay, thank you so much, sir.
Sir, good afternoon, sir.
Yes, sir.
Good afternoon, sir. I am Omkar from Aditya Degree College.
Sir, Aditya Degree College మొత్తం ప్రశ్నలని మీరు అడుగుతున్నారు.
Sir,
Let
internal
others.
hackathon is different from external hackathon. Problem statements.
Sir?
Same.
Or should we conduct same 10 problem
Same.
statements for internal
Yes,
hackathon?
only you have to choose only out of 10 problem statements, you have to conduct internal hackathon.
But the problem statement should be in those 10 problem statements.
Yes. Whatever we have given, those only you have to select.
Okay, okay, sir. Thank you.
Sir, this is a special edition exclusively for quantum.
Sir, I'm Dr. Suryakumar from Padmavati University, sir.
Yes, sir.
Yeah, for this, till now we have completed the SPOC registration and the teams registration. I think by 26th we need to register the titles, if I'm right.
Yes, sir. Yes, sir.
So for that also in the portal, hope maybe you can guide us where to upload the titles.
The portal, everything is on there, sir. Portal, it is now working.
Okay, so because there was a form submission was there for that. So submitted the title also, we just like to, so we'll I think by 26 we need to upload the titles and 28 is our internal hackathon.
Exactly.
For the internal hackathon, hope the jury, because are outside us, if they cannot come physically, maybe we'll take something online also.
No, sir. Every college, they will conduct internal hackathon, they will submit the results, sir. That's it.
Yeah, and then the semi-finals is on 10th, that's what it can be.
Yes, sir.
Thank you.
Good afternoon, sir. Good afternoon. I am Dr. Sri Nagesh from RVR and JC College, Guntur, sir. So, what are the basic guidelines for evaluation, internal evaluation? We have 9 applications.
No, everything we have placed in the website as a guideline. You can you please go through.
Okay, sir. Apart from that, where we have to send this semi-final students, regional center. So after regional center, finals will be held in which place, sir?
We will tell you, sir. Mostly it will be in Acharya Nagarjuna Street. Otherwise, if any venue changes there, we will let you know.
Okay. Thank you, sir. Thank you very much.
Yes, madam.
Good
please,
afternoon, sir. We are from Vidyajyoti Institute of Technology from Hyderabad. Sir, actually there is low response from our college. Like we are just one team. So there is no internal hackathon from our college. So can we directly join semi-finals, sir?
No, wait. How can you join directly semi-final? You have to conduct internal hackathon within your institution. That is the facility, madam. So how many students are there? How many students are there?
So just one team from our college.
That means six students are there.
No, sir, just 4, sir. Team of 4 students.
Yeah, you have to conduct internal hackathon and you have to submit on our portal, and we will also verify that, and we will select that if it is valid, or we won't select it if it is not valid.
Okay, sir. Thank you.
Okay. Thank you, madam. Any other colleges? I would like to invite our SPOCs, Regional Center SPOCs. Dr. Anuradha madam from Gayatri Vidya Parishad, please. Can you say something, madam? Dr. Ravi Kiran Varma garu from SRKR Bhimavaram. Varma garu leru, madam leru. Sir, Dr. Madhukant garu from Danekula.
Sir, am I audible, sir? Am I audible, sir?
Yes.
Anikula, sir.
Yeah, please, sir. Sir, anything you want to say?
As of now, nothing, sir. Students are asking about any detailed description about the problem statement, sir. One of the question I found.
Yeah. Tomorrow session will be on these only because two experts actually from industry, the startup industry, they will deal with the detailed discussion will be there tomorrow.
That is the one, sir. And among the 10 statements, we are going to select 5, sir.
No. You
Best
have to
5, and we are going to pick best 2, sir.
That is for results, sir. But you have to conduct hackathon for all the 10 problem statements.
Yeah, yes, sir. Entire teams we are going to conduct. From that, we are going to select best, and that too we are going to select finally 2.
Yes,
not specific to the problem statements, sir, right?
Yes. And I request, sir, all the regional centers, please, even colleges also, please give wide publicity about this hackathon in your print media, in your telemedia, in your social media also. Please involve more and more students, sir, because Honorable CM Garu set a target of 1 lakh students. I think in this today's program, only 20,000 is there. I expect more students by tomorrow. And I request Dr. Surya Kumar Garu from Padmavati Mahila University.
Yes, sir. So regarding the regional
Sir, hackathon.
Get the list of the colleges which will
We
be.
will share again, sir. Today we will share again.
Yeah. Please share because we should know, because from each college,
Yes, sir.
teams will come. So we should know how many will come on that day and all that. So that
I will.
That will help us.
Sir, from your side, as you are already involved in such type of innovations and hackathons, kindly give wide publicity about this.
We'll definitely give. I'm only curious because how many colleges
I will give, sir. I will give by evening.
Okay.
Because today also so many are submitting the teams. And one more thing, many SPOCs, they didn't submit teams, sir. Please kindly submit through the Google Sheet. And I request Professor Suma Bindu Madam from JNT Anantapur. Madam.
Good afternoon, all of. Good afternoon,
Madam.
also. Sir, like we are from JNTU and we do have 5 districts under our control. So we have given the circular to all the engineering colleges. But what I find here, the difficulty is like the regional center you have given to us, regional, for conducting this hackathon. So where we have Anantapur district and Kurnool district, and there are certain degree colleges which have registered for this. We are not able to connect to them actually. That is the problem that we are having.
I will share the details, madam. You can connect them.
Yeah, yesterday I have taken the list, whatever you have shared. From that, I have tried to form a Google, WhatsApp group also. But because I'm not known to all those people, they are not connecting, they are not enrolling themselves, or I have sent an invitation, but they are not joining the group because they are not known to me. That's the problem, I suppose. I think so, sir.
We will coordinate, madam. We will coordinate and send you data again. And also, I request you, madam, please give wide publicity about this.
Yes, sir. To all the principals we have circulated through WhatsApp as well as through emails also.
And also give a publication in newspapers and telemedia and social media also.
Yes, sir. Sure, sir. Okay.
Sir, Ravi Kiran from Bhimavaram, sir, unnara meru? And Dr. Anuradha from Gayatri. Sir, somebody from Gayatri, anybody can speak if madam is not available there. Gayatri College students are there. It is a regional center, you have to. Yes, madam. Any issue is there, madam, please?
Yes, sir. Good afternoon, sir.
Madam, any issue is there with your?
Yes, sir. Yes, sir. One student. No, sir. No issues, sir.
Okay, okay. Thank you. And Ravi Kiran garu, anybody from SRKR College, Bhimavaram? Bhimavaram. SRKR College students unte maatladam evaru unte. This is a regional center. Yes, please. SRKR College. Please. Okay. Please inform them SRKR College Ravi Kiran Verma garki alage students. So I request all of you, please join by 1:30 tomorrow. Tomorrow are very good sessions. Directly they are dealing with the problem statements and solutions and other softwares also. Because these are the industry people actually working on this. Thank you for joining. Yeah, madam, please.
Sir, I'm Madhukan from Danekla, sir. Sumaru from 1:30 to up to
Yes, sir. 1:30 to 5:30 untu, sir.
5:30, sir. Okay, okay.
Yes, madam. Sibar Institute of Dental Science. I welcome madam Dental Science join in.
Myself, Dr. Sarita from Sibar Institute of Dental Sciences, sir.
Great,
Sir,
madam.
actually, I think regarding the problem statements, what we have seen, it is actually related to all the engineering side, sir. But can we participate, because we have three teams from Sibar Institute of Dental Sciences incorporating quantum technology in dentistry? Can
100%,
we
madam.
participate,
No,
sir?
no, actually, what you said is right. But being it is a multidisciplinary, you can participate.
Yes, yes, sir.
You
Yes,
can
sir.
participate. You can
Okay,
participate.
sir. Thank you, sir.
And we congratulate you for joining this quantum movement. Being a
Sir, we
dental
received
doctor.
a circular from NTR University, sir.
Before that, madam, kindly register your institute.
Sir, I have already registered and the teams also have been registered.
Great, great. Thank you,
Sir,
madam.
actually, regarding internal hackathon.
No. Have you registered in the under SWOG category?
Yes, sir. Yes, sir.
Okay, wait, I will check again.
We have registered. My name is also there, sir. Our institute name is also there, but the teams' names were not reflecting in the teams.
Okay, we'll check. Have
Only
you
one
submitted?
team has been reflected, sir. Other two teams have not been reflected.
Okay, otherwise you can do one thing, madam. You please submit again. That is better.
Okay, sir. In the same Google Forms.
Yes.
Okay, sir. Sir, regarding internal hackathon, can we have any experts regarding quantum technology to conduct internal hackathon in our institute?
Yes, that is what.
Sir, can you please suggest one of
Yeah,
your...
sure. You please call me again. I will give some numbers.
Okay, sir. Okay, sir. Thank you, sir. Thank you so much, sir.
S plus SRKR Engineering.
I am from SRKR Engineering College.
Babu, మాట్లాడు స్టూడెంట్ ఫ్యాకల్టీనా?
Student.
సార్ లేరా మన రవికిరణ్ గారు లేరా?
లేదు సార్. లంచ్కి వెళ్ళారు.
సరే, ఎంతమంది అటెండ్ అయ్యారు మీరు?
Sir, actually, I'm the faculty of SRK Engineering College, sir. Just I went for the meeting, sir.
ఎంతమంది అటెండ్ అయ్యారండి స్టూడెంట్స్?
Student nearly 153 to 200 members attend.
Very good.
Just now for lunch we leave them, sir, because
Okay, sure. Tomorrow please join by 1:30.
Yes, sir, definitely, sir. They are still up to now. They are here, sir, 1:30 up to now. Just a lunch break for them, sir. Actually, 12 o'clock lunch break, sir. We left them just now, sir. The hostel facility closed, sir. That's why we left them just now, sir.
Okay, thank you, madam. Thank you.
Okay, sir. Thank you.
So I wish you all good luck. So if no doubts are there, we will close the session for today, and tomorrow I welcome you all to join by 1:30 p.m. Thank you all.
Hello, sir. Myself, from ANDHRA Degree College, Pune. Am I audible?
Yes, audible and audible, Chapan. Yes, sir, audible. You are audible.
Yes, sir. Sir, from our college also, they, 10 teams are registered, but their teams are not reflecting in the portal. Please help me on it.
మీదే కాలేజ్?
ఆదిత్య డిగ్రీ కాలేజ్ తుని బ్రాంచ్.
ఓకే, మళ్ళీ ఒకసారి సబ్మిట్ చేయమండి ఒకవేళ మిస్ అయితే. ఆల్రెడీ ఉందా? ఓకే ఓకే, విల్ చెక్ సార్. ఆదిత్య ఒకే ప్లాట్ఫామ్ వస్తే బెటర్ ఏమో, మల్టిపుల్ ఆదిత్యస్ ఉన్నాయి, వేరే వాళ్ళకి ఛాన్స్ రావట్లేదు. ఓకే, so if there is no issue and there is no query, we will close, and thank you one and all.
Thank you, sir.